Welcome back, 7th grade. We're in your Eureka workbook, Module 1, Lesson 4, Identifying Proportional and Non-Proportional Relationships in Tables. You may notice that the title from this one is the same as the title from Lesson 3. So we're going to be continuing our discussion on proportional and non-proportional relationships in tables. So there is a lot, this is a very dense classwork section for you students. So we're going to come to example 1, and I'm going to read this as you read silently. You have decided to walk in a long distance race. There are 2 teams you can join. Fantastic. Team A walks at a constant rate, 2.5 miles per hour. Don't let my line Don't do 2.5 miles per hour for Team A. Team A going 2.5 miles per hour. Great. Team B walks 4 miles for the first hour. Okay. And then 2 miles per hour after that. Your task is to create a table for each team showing the distance that would be walked for times of 1, 2, 3, 4, 5, 6 hours. So you're going to come down here, and for table A, let's see if we can get the whole thing on here. For table A, you're going to figure out for the first hour, so time in hours, the second hour, third hour, fourth hour, fifth hour, and sixth hour, how far would they have gone in miles based on the information we're given up here. And you'll do the same for Team B. Create a table. How far will they go in the first hour? How far will they have gone in the second hour, third hour, fourth hour, fifth hour, sixth hour, right? So you are going to spend approximately 10-15 minutes on this exercise right here. Now you may be thinking that this isn't much to fill out right here, but if you're looking at the page, maybe you go down, oh, well, we have some questions to answer as well. So I want you to go ahead and answer questions A through G that are associated with example 1. Again, put a timer on you, give yourself 15 minutes, and you can work through A through G for example 1 after you have filled out the tableau, right? So use the information that you have up here. How far will they have gone right here? Okay. All right. So for Team A, we should have found that in the first hour, Team A would have walked 2.5 miles. They travel at a constant speed of 2.5 miles per hour. So in the first hour, they'll have traveled 2.5 miles, right? So in the second hour, they'll have traveled another 2.5 miles to get to 5 miles, right? Because 2.5 plus another 2.5 equals 5, right? Now we're going to continue this trend and we're going to go another hour, right? So we're going to add another plus 2.5, right? We're going to add another 2.5 miles, which when we do that, we'll be at 7.5. Right? And this trend is going to continue at a constant rate each time. Each time we're going to go up 2.5 miles. So we'll be at 4 hours we'll have traveled 10 miles. At 5 hours we'll have traveled 12.5 miles, and then the last 15 miles. Right? If we're on Team A. Correct? All right, but what about Team B? So what did you come up with for Team B? How did you fill out that chart right there? Let me know. Those were some very interesting and creative solutions. Thank you for your effort. Fantastic. So what you should have found based on the information we're given, Team B walks 4 miles the first hour. So under our first hour right here, under 1 hour, they would have traveled 4 miles. Then 2 miles per hour after that. So for every mile after that, we traveled 2 miles per hour. So going up from here, we added 2 miles. So in the second hour, we would have traveled 6 miles. And every subsequent hour would have been at a 2 mile per hour rate, right? So we're adding 2 miles each time to each hour. So if we go to the third hour, we're adding 2 more miles, 8, 10, 12, 14. So if you haven't already, give yourself some time to answer these constructive response questions down below example 1 while I read them aloud. For which team is the distance proportional to time? How do we determine if something is proportional? Explain how you know. Explain how you got there. Explain how you know the distance for the other team is not proportional to time. So again, how did we determine one was proportional and the other one isn't? Is what they're asking, I guess. Explain how, yeah. Yes, explain how the one is proportional and the other one isn't. Part C, at what distance in the race would it be better for Team B than Team A? So, for this one, you can go look at your chart right here that we worked on together now, so you can reflect back on the information from the chart. At what distance is Team B better off than Team A? Explain why. Use complete sentences. If the members on each team walked for 10 hours, how far would each member walk on each team? If each team member walked 10 hours. Oh, right. I don't think we have that many hours on the chart, right? Okay. So what they want you to do is continue the chart on each side, right? So you're going to keep going. Maybe you want to give yourself some scratch paper, write it out 8, 9, 10 over here, right? And then 7, 8, 9, 10 over here, okay? And then calculate that out. I'm going to undo that. I'll be right back. All right, moving on to question E. Will there always be a winning team no matter what the length of the course? Why or why not? Another way to think about this is, could we have a tie? Could we have a tie? So could we have a tie? Why or why not? If the race is 12 miles long, which team should have to be on if you wish to win? Oh, okay. So if it's a 12-mile long race, which team is going to win, right? If the race is 12 miles long, who wins? Okay, kind of shorten that question up for you, just so you kind of understand it a little bit easier there. Okay. Question G: how much sooner would you find that team compared to the other team? How much sooner would you finish on that team? Okay. So again, we're going back to the last question with G. So with question G, go back to F. If the race is 12 miles long, then, okay, if the race is 12 miles long, then how much sooner would you finish on the winning team than the other team? right? So how much would you win by if the race was 12 miles? All right, so if you haven't already, take your time, answer those questions. Give yourself 7 minutes on those if you haven't already. Okay, so these are some examples of some A+ work answers to responses to these problems right here. This is directly from Eureka itself. You can pause it right here if you want to just take a look at it and read them yourself. I'm going to go over them kind of quickly. That's A through D, and then the rest E through G right here with some notes alongside to go with it. Now look. All right, so for which team is the distance proportional to time? Their answer, the distance is proportional to time for team A, since all the ratios compared to distance are equivalent. The value of each ratio is 2.5. Every measure of time is multiplied by 2.5 to give us the corresponding measurements of distance. That's a lot, and you don't necessarily have to write all that, but 2.5 is the key number here, right? Like we talked about. We multiplied with the first hour times 2.5, and we traveled 2.5 miles. After the second hour, so multiplied 2 times 2.5 to get 5. Same thing with 3. We multiplied 3 times 2.5 to get 7.5, and so on. So the constant there was 2.5. That was always part of the ratio, right? Or it was the ratio of distance to time. Very good. Okay, so part B, explain how you know the distance for the other team is not proportional to time. What sets this one apart is the first one. So let's look at the first one. So in the first hour, travels 4 miles. So 4 miles over 1 hour, that's 4 miles per hour. So that's 4 miles per hour. Let's look at the second one. Travel 6 miles in 2 hours. That is 3 miles per hour. So these are not equal, right? So already our rate is changing. Then we go to 3 and 8. 8 miles, 3 hours. Already that's going to be something not 3, right? So it's changing every time. I think it's something like that. But anyway, we already know that it's not proportional. So that's a fantastic answer right here. I have no problems with the way they said it. If you make sure you use your complete sentences to answer those questions. Check your rubric. Part C, at what distance in the race would it be better to be on Team B than Team A? Explain. If the race were fewer than 10 miles, right? So let's go back to our list here, right? So Team B kind of comes out hot, right? Team B came out fire, and they traveled 4 miles in the first hour, right? So if the race is 3 hours long, well, they're going to go 8 miles compared to Team A's 3 miles, 7.5, 3 hours, 7.5 miles, I should say. And then they'll meet up at 4 hours if they go at this pace, right? Fantastic. Okay, so they'll meet up at 4 hours, but before 10 miles, it's more advantageous to be on B's team. Okay, great. I love the way they responded. Okay, you responded. You did great. Thank you for your effort. Part D, if members on each team, if members on each team walk for 10 hours, how far would each member walk on each team? Okay, so the question is, how far would each team go in 10 hours, right? How far does each team go in 10 hours? Was that one of the questions that I had asked over here? I don't remember. That was this one. And remember, we talked about maybe you want to build a little bit longer of a table so you can fit all this in, right? So at 10 miles, we would just keep adding 2.5 as we would go down, or we could just multiply 10 by 2.5 since that worked up here. So we multiply 10 times 2.5 to get 25 miles for team A. And then for B, you can just kind of keep going up by 2. So 16, 18, 20, 22. Right? Is that correct? Yes. Good. Okay. Very good. And that is a sufficient answer. Great. Will there always be a winning team no matter what the length of the course? Why or why not? Could there be a tie? Was how I phrased that. No. There would be a tie. Oh, right. Okay, because of the way they phrased it. They're saying that there could be a tie, and it would be at 10 miles. There would be a tie at 10 miles. I just don't love the way they phrased that question. But again, if you mentioned that they would tie at 10 miles, that's good enough. If the race were 12 miles long, which team should you choose to be on if you wish to win? Why would you choose this team? Okay, so if the race was, let's go back up and we can check on our chart here. If the race was 12 miles long, well, team B is going to take 5 hours. Oh, if the race was 12 miles long, who would win? Well, team A would win because we determined that anything past 10 miles, advantage goes to A. So if they tie at 10 miles, then 12 miles, A is going to be beating them, right? That's how I would answer that. I don't know if they did some math on that. Yeah, I wouldn't. You could use some intuition on that, but yeah, they did some math. They figured out how long it would take each one of the teams to do 12 miles. So as you can see, Team B is slightly slower in there. Great. How much sooner would you finish on that team compared to the other team? 5 hours minus 5, 4. Yeah. Okay. So, all right. So this problem actually takes a couple of steps here, right? All right. Team B, we already know how long it's going to take them to go 12 miles. It'll take them 5 hours. Now, we don't know exactly how long it's going to take Team A to go 12 miles because we don't have exactly 12 miles on our chart here, right? But let's think about our constant here, 2.5. So we're using 2.5. We were multiplying the number of hours times 2.5 to get to our miles, right? So that means if we go in reverse, if we go the other way, we can divide by 2.5. 2.5 divided by 2.5 gets us 1. 5 divided by 2.5 equals 2. It goes back, right? So if we have the case where we have traveled 12 miles for Team A, well, all we would have to do is divide by the constant, 2.5. That makes sense the way I did it. So we have 12 divided by 2.5, which remember your long division skills, and we'll divide 12 divided by 2.5, and we get 4.8 equals 4.8. Okay, now, so since Team B finishes in 5 hours and Team A finishes in 4.8 hours, that means you will finish 0.2 hours ahead of the other racers. So I would finish the race 0.2 hours ahead. Now, they actually did some math to figure out that 0.2 hours is 12 minutes or sooner, and they did that by calculating 60 times 0.2, which gets you 12, which is just translating from hours to minutes. So good on them. Very good. I would accept 2.2 hours. That would be fine for me as well. I would work with that. Okay. Exercises 2 and 3 now below. And these are some more independent exercises. So you're going to try these on your own. Okay. So go to the next page. Continue on to exercises 1 and 2, and you will do these independently. Give yourself about 10 minutes. Um, you can read them on your own or follow along as I read. In question one, Bella types at a constant rate of 42 words per minute. 42 words per minute, constant rate. Is the number of words she can type proportional? Is it proportional? That's the question to the number of minutes she types, right? Create a table and determine the relationship. So, is it proportional? Answer. Is it, and then finish up the table. You got it. And remember your rubric. Mark, question two. Mark recently moved to a new state. Awesome. During the first month, he visited 5 state parks. I remember this question. Each month after, he visited 2 more. Complete the table below. Okay, and determine if the number of parks visited is proportional. Is it proportional? So, is it proportional? Right. Chanel. Good. Finish this chart. Great. Okay. Question three. Question three. The table below. The table below shows the relationship between the sides. This shows the relationship between side length of a square and area. So one is side length, one is area. Actually, we're going to come right back to this. All right, so in exercise one, fantastic work, by the way. Thank y'all for working so hard. In the first problem, Bella types at a constant rate. So already I know it's at a constant rate. Is it proportional? Yes, already. Okay, great. 42 words per minute. So the first minute she'll have typed 42 words in that minute. Then the second one she'll have doubled that. So we'll multiply 42 times 2, 84, and then multiply it times 3 to get 126. And that follows from there. We multiply 6 times 42 to get 252. And then 60 times 42 gets me to 2,520 words in 60 minutes. So just to kind of nitpick about this for a second, let's say that Bella actually types for 60 minutes. Do you think she's going to be able to type 42 words per minute for an entire hour? I don't think that she's going to stay constant at that. That's just me. So definitely proportional, and our rate is 42 words per minute. We filled out the chart, looking good. Great. Okay. Question 2. Please don't make me pause. I really like the second question just because of how weird it is. So good for Mark. He gets to move to a new state. Great. During the first month, he visits 5 state parks, and each month after, he visits 2 more. So is that forever? Is he going to visit 2 state parks every month forever? I don't I don't know if that's possible. I don't know if there's that many state parks. What state did he move to? Who knows? So anyway, that's beside the point. Okay. All right. So how many state parks will Mark has seen in the first month? In his first month, how many did he visit in the first month? Very good. He visited 5 state parks in the first. Okay. So, but what about the next month? How many parks will he have added to his total? Huh. Well, each month afterwards, he visited 2 more. So the next month he will have added 2. And the month after that, he'll have added another 2. So he'll be at 9 state parks. Uh-oh, though. What about at 23? How can we figure out how many months, how many months Mark's been living in the state if he's seen 23 state parks? So one way you may have gone about finding this answer is just by expanding your table a little bit, like I did right here. So over here I have months, and over here I have parks, and I just kind of stretched the table out, right? So first month we had 5 state parks, just like we did in our original. Second month we had 7 and 9, just as we did in our other chart. Now we just continue, right? So we're going to add 2 each time. We're going to go up by 2, 11, plus 2 to 13, plus 2 to 15, so on, 17 to 19, until we get to 23. That's what we're looking for, right? So that's the magic number. So we're going to add 2, get to 19, plus 2, get to 20, 21, plus 2, get to 23. So in his 10th month, he'll have visited 23 state parks, which means there are a lot of state parks where Mark lives. So the question remains, is it proportional? Well, let's find a unit rate for each one, right? So let's divide this by this, right? The state parks by month. So in this one, it's 5 over 1 or 5. So that means if we divide 7 by 2, if it's not 5, then it's not jive. 5 divided by 2, 7 divided by 2, 3.5, 3.5, no. No, it is not proportional. The unit rates are different. No. There is actually another way to solve problem 2, but we're not going to talk about that in this lesson. Instead, let's move on to question 3, exercise 3 in this lesson. And you can skip this one, whether you're at home or in class with me, we can skip over this one. But if you would like to challenge yourself, this is sort of a fun one, okay? So we want to figure out the relationship between the side length and the area of a square, okay? So let's think about what we know about squares, right? So I'm going to give you a minute. It'll take a second. You pause, see if you can fill out the rest of this table. Okay, so let's find out whether you got that right. Okay, so length of the side of a square, right? What do we know about a square? We know a square has equal sides, right? So whatever the length of one side is, it's going to be equal to the others, right? So if a square has a side length of 1, how do you determine the area of a square? Anybody? We find that by multiplying length times width. So the length times the width. Well, the length and width are the same in this. So in this example, our length and width is 1. So 1 times 1 equals 1. So if the side length is 1, area is 1. The side length is 2. We multiply, again, the length times width. In this case is 2 times 2, which would be 4. So if we follow this pattern down, if we have a square that's 3 by 3, then we'll have 9 square units inside of it. And if this follows down, 4 times 4, 16, 9, 16, 25, 64, and then 144 square inches. But this is not proportional, right? It is not proportional. No, because it changes each time, right? So from 1 to 1, we multiply times 1. But here we multiply times 2. And then we multiply times 3. So our unit rate doesn't stay constant. So it's not proportional, right? And for example 2. Okay, so you can move forward to the problem set. If you're at home, remember you can respond to these problem set through the forums that I provide you, the Google forms I provide. Check your email for those. Email me if you're not getting them. Thank y'all. I'll see y'all in the next one, next week maybe.